interaction with IIT Madras course. Hello, Pawan Kumar.
It is tomorrow, sir. I think tomorrow 6 to 8.
But so far, no interaction has happened.
Yes, sir. Yes,
Happened,
sir.
sir.
Happened, sir.
What are the things they discussed?
They discussed the first week content, sir.
And our studio also they have been discussed, sir.
Huh?
Studio.
R only mostly they discussed about R, sir.
They discussed only with R. Okay. So, are you able to complete the assignments in time?
Yes, sir.
Okay. How many people have submitted the assignments? How do I know? What I will do is, I think we have to use some. I have to use some tools to ask queries and then get the answers. Maybe tomorrow, next case, I will ask. Okay. And so now, which video lesson is going on? In the module, in our tool, which you in data science course, which lessons you are reading now? Video number 3 or 4?
Now third week has to be submitted, sir. 18th is the last date for submission of assignment, sir.
Okay, third week. Okay, right. Okay. So anyway, still you are in the beginning. Okay, that's what I am able to understand. So now let us continue our discussion. Yesterday I started topic number 10, OLAP and data warehouse systems. Right. So we will continue the topic today. So I hope the slide is visible, right? So I am going to talk today what is online analytical processing. Okay. So there are, as yesterday I talked about different transaction processing systems, and today I will describe how analytical processing systems are different from transaction processing system. Why do you require? What are the key features? And what is the support as provided in SQL, etc. Right? This lecture may take 2-3 hours time, but depending on the time, I will stop in between and then continue tomorrow also. But before going, yesterday, how many of you have attended AI SQL using AI workshop? Yesterday, I shared, day before yesterday, I shared on workshop, right? AI for techies. Did anyone attend it? I think somebody is raising the hand. You can tell. Yeah. Iftikhar Hussain and Vani.
Sir, I attended the session, sir. It was using AI tools for SQL, sir.
Yeah, that's what, using AI tools for SQL.
Yes.
Can you share what are the quick things so that others also will get some experience on how to learn quickly SQL?
Sir, they spoke about the different AI tools like w3schools.com, wherein which you can take the data required for the SQL and you can perform so many operations on that. Then they spoke about the Claude tool, which can, based on the artifacts, it can generate the SQL required analysis thing, including the diagrams. And then they spoke about the Gemini tool to update on the MySQL. Like if you want to learn from the beginning to end, learning about the MySQL language, Gemini tool will help us. How to use the Gemini tool to understand SQL, they spoke. And
Gemini is also AI tool developed by Microsoft, I think.
Yeah,
okay.
Google.
Yes, sir.
And this Google, and this will help how to quickly get the data and how to transport the data and all those things, how to manage the data, all those things you can do. Okay.
Yes.
Right. Next.
They spoke about the Perplexity tool.
Perplexity. Okay.
Lead code also. for optimizing AI tools with the
Yes.
lead code. They spoke
Okay.
about that, how to use that. Then they were telling about the data pipelining, how to use AI for data pipelining. They spoke also about the cursor tool, Julius, all those things, which will create the dashboard and the visualization for SQL.
Right. See, now see, yesterday they gave a 3-hour talk, right? But I am not using the tools, but I know what are all the things they have taught, and then they also asked you to practice in that direction, right? Okay. So now if you observe, if I want to teach SQL complete to you, it will take another 15 hours time, my time. But we don't have that much time here. So that's why what I thought is, I asked you to ultimately, you have to be familiar with one database, right? In some form you should learn, and then you should be able to query the database and then get the results. That is what the SQL basically. SQL basically helps you to retrieve the data from a database by identifying, by spelling, by telling what you want to extract from the database. What you want to extract, you are telling, but you are not telling how to extract it. How to extract is driven by the processing at the back end by the database engine, and then it provides the right results to the right user at the right time. This is a brief summary of the SQL processing, right? But we are not going into the too many details of the database course because it's a full-fledged one semester course. But here, for understanding our course content, you need to understand SQL little bit, and then you should understand what for SQL is used and what are the advantages you get. Once you know that, then you can compare day-to-day transaction systems, how it will behave, and how analytical systems behave. That is where I talk about more on OLEP. Keeping that in view, I asked you to attend this workshop. I'm happy that at least some of the participants have attended. Maybe Vani can present. Vani, can you demonstrate whatever you have learned yesterday to the audience? Maybe tomorrow.
Okay, sir.
You prepare some slides and demonstrate.
Yes,
Demonstrate means you have to create a simple database. Maybe your participant list, you create a database, and then capture some data related to participants using your Moodle or whatever Google form you are using, and then create a table, and then run some queries using W3C schools or AI tools, Perplexity, whatever tools. Ultimately, all these tools, it is useful not only for you, in fact, for your own students, non-computer science students in your department, wherever you are working, you can motivate your students to learn these things. So that, so what is the advantage you get by learning these things? As the last topic, what he presented is 50. Instead of sitting idle, by sitting idle, we can earn 50% of the hike of your salary. That is also he has highlighted, right? So everybody should now, job roles are changing, and job coding skills are reducing. So more analytical skills are required. So in order to inculcate those skills, we need to use these AI tools like Perplexity, Gemini, and Cloudera, and visualization tools to create dashboards, etc. You are of course learning some visualization tools using R and Python, but all these tools are AI tools will help you to create the dashboard quickly also on some application. So these are all some of the things that you can practice. So anyway, tomorrow Dr. Vani is going to give maybe 10 to 15 minutes presentation and demo in tomorrow's class. Okay, before starting my material, I will request Vani to deliver. Okay.
Okay, sir.
Okay, Vani.
Okay, sir.
Right. Okay. So share all the details so that those who have not registered also will get exposed to this domain. And since you have attended the workshop, how are you transmitting also, you can test by yourself. So both sides, it is useful for us. If any issues are there in between, I will help you to resolve the problems. Okay.
Okay, sir.
Right. Okay.
Sir, but
good.
as per my knowledge, many of the participants has not got the link to join the session, sir, yesterday.
No, but it's okay. But without link also, without link also. Now anyway you are going to present. We will instead of spending 3 hours, we will show and then explain to them in half an hour. Okay.
Okay, sir.
Concept I will explain. No
Okay, sir.
problem. Okay.
Okay, sir.
Concept I am going to explain and then I will tell you. Okay.
Okay, sir.
Right. Okay. Right. Anyway, thank you. So let us start our lecture. Okay. So this slide is visible, right? So these are some of the topics I'm going to cover today. Assume that you have some database and you have a little bit of exposure, but wherever support is required, I am going to explain in a more informal way to understand the key differences. Technically, you have to practice certain things in the lab. Okay, right. So what for OLAP? As I said, OLAP stands for Online Analytical Processing. So this OLAP is a tool actually. These tools are based on the back end of some strong mathematical foundation. So they are useful for answering demand-oriented questions. So demand-oriented questions can be answered. What is the highest average? What is the large data will be there, and you may want to get some comparison, some analysis, etc. Such questions are called demand-oriented questions. And what OLAP basically makes is, OLAP makes data synthesis, data analysis, and data consolidation. That means aggregation, summaries, and then analyzing, and then combining the data. Everything you can do in a quicker, smarter, and easier. 3 simple words. Quicker means easily you can do. It is not quicker than our AI tools, but this is a tool developed a long time back. But quicker, smarter, and easier from the existing database, old database, legacy databases point of view. This makes data synthesis, data analysis, and data consolidation quicker, smarter, and easier. And it is also used for efficient retrieval, and also it assists in making business decisions in a more formal way and in a better way. So the institution-based decisions we don't encourage. Here we take the decisions based on the data. So data-driven decision. So data is only guiding you to take a decision into a particular form. That process is going to become easy and better and efficient by using OLAP. So actually, famous mathematician Cod in 1970, he only developed the relational database management system model, and he stated that relational database systems are used for users. Those days, they never intended to provide more powerful functions for data analysis, data synthesis, and data consolidation. That means this statement was given in 1993 in a popular magazine called Computer World by E.F. Cod. He is the father of relational data model. So he only developed certain rules, which we call as Cod's rules. These Cod's rules, those days when he has developed the Cod's rules, those rules are never intended for providing more powerful functions, data synthesis, and data consolidation facilities. But today, because of the technology, because of the rapid growth in changes, because of more availability of the data, OLAP makes synthesis, analysis, and data consolidation quicker and smarter, easier. So this was the comment given in 1993 by Cod when they invented this OLAP system. So therefore, what is the basic ground reality? The basic ground reality is analysis requires data. Not all the data. Analysis requires analytical data. If data is not related to analytical orientation, then whatever analysis, if I put only names of the faculty as one column, if I want to do the analysis of the names, it is not relevant. But whereas if I put names, designations, and age, then I can make some analysis on old age faculty versus I can compare the performance of old age faculty versus middle age faculty versus engaged faculty, or based on the cadre, etc. So that's why whatever the data you take, that data must have inherent analytical capacity and capability. So that data only should be taken as input for this system. So people call this as a OLAP as a very high capacity multi-user, that means several users simultaneously can manipulate the data, specifically designed to operate on multi-dimensional structures. So your data structures are and different perspectives are taken into consideration. Yesterday I talked about data warehousing, which is a subject-oriented. The subject-orientedness gives you different dimensions or different perspectives of the data. Under these perspectives, we combine and then prepare a model, and then we do the analysis on top of the model. That's why it's a high-capacity multi-user DML engine. For example, if you take market basket analysis, the different subject headings can be what are the different products available, in which organizations these products are there, are the organizations same or more than one organization producing the similar products, and which type of customers are going to buy these items, what is the relationship exists between the product. A customer can buy several products from several organizations at several times. So time dimension is also can be included here. So then what is the amount, maturity amount, interest rate? These are all related to measures. If you take banking into account. Sales is if you take product customer dimensions into account. So what I want to say here is measures are important. Measures are derived on the combination of dimensions. So the customer, product, and organization, bank, or whatever the dimensions you take under the combinations, measures are computed. So without these measures, you cannot do any analysis. Okay. So therefore, OLAP is there is a council called OLAP Council. This council has defined formally OLAP as a software engine, which has several properties like security, interactivity, customization, and visualization. All these four properties are integrated through a structure. The OLAP is a structure. This structure basically integrates all these four parameters to get insight into the data through a fast, consistent, and interactive access. So, see, if you observe, the normal databases are not fast, but they don't give any interactive access. They always give, if you submit a request, it will give an answer. It won't, if you want to have more answers, you have to submit more requests. So there is no interaction during the running time. So therefore, this OLAP system provides a fast and consistent results, analytical results, and interactive access to different possible views of the information, which can be how that information is derived, that information is transferred from raw data to reflect the real dimension of the enterprise. So that means what? To understand the market dimensions, to understand the organizational growth, to understand the analytical results of the sales of an organization, we are combining all the things in the different perspectives by taking the interactivity, security, customization, and visualization into consideration. That's why OLAP Council has defined this as a software with 4 qualities. So what is interactivity? Interactivity means it provides a ease of access with the tool. How easy it is the user to access from the data to get the analysis, that is called interactivity. But here in the normal databases, interactivity is very low in the sense that we never interact with the database. We submit a request, database engine runs the query, and then provides the results back to you. There is no interaction between these two. But whereas here, in the interactivity in the OLAP tool, we always ask the lower results, high-end results, summary results, medium results, mid results, etc. I'll give an example here, interactivity. Then customization. How easy the end user make changes on the data representation provided by the tool. So suppose somebody has represented some data in some form. Can I transform the data into the way the end user wants, the customer wants. So that's called customization. Then visualization, how easily the tool provides graphical representations. Then how to protect the analysis insights. That's a security. So all these things are collectively embedded in the OLAP software. That's why it's called OLAP. So OLAP can be compared in a different perspectives. From the nature perspective, how it looks like. From the nature perspective, the different parameters are shown here. See, because in the textbook, this information is given in pages, 4 to 6 pages. But everything I combined and consolidated into simple, concise representation without using terminology too much. For example, contents-wise, how my data in OLAP looks like. Data contents-wise, OLAP data is summarized, archived, derived, or historical. In the sense, as I said, the past 5 batch passed out students' data is historical. And sometimes some data may be derived because different students' results processing in different colleges may be different. But I have collected them in my repository, all the students of all colleges for all batches passed out. So it is derived. Then sometimes we may take a backup storage and then extract. That's why sometimes you may have to take backups archived and then summarized. You are not extracting every minute details from the raw data. You are doing analysis on summarized. So data is represented in a highly summarized form. More higher the grain, lower the size. This is what I mentioned in the yesterday's class. Based on the granularity, the size of the data warehouse will be decided. Therefore, we have to put more summaries into the data warehouse so that we can reduce the data size. So this is what the contents wise. Then organization. Organization wise, the data is organized by taking subject headings into consideration. Customer, time, then accounts, students, teacher, etc. These are summary subjects, right? Then stability. How tightly you have stored the data in a data warehouse, in a OLAP data. OLAP data is highly stable for running the queries as quickly as possible. It's optimized. Optimized for complex queries. Complex queries means what? Huge number of combinations of summarized data is available. So on back end of that data, we are doing processing very quickly. The why it is quickly, the time that takes on the normal database is very, very high compared to the time that the OLAP takes on running the on top of the data warehouse is very fast. That's why they're optimized for complex queries. Then frequency, how frequently you will access. The frequency is always accessed very, very, very minimum and to low. In the sense that you don't do an analysis every day. We do analysis once in a while. But whereas day-to-day operations, every day, every second it is performed. So therefore, the access frequency is very minimum to low. Then type of access is read-only access or summaries, aggregate access. There is no record-by-record access. All summaries are only accessed. That's why type is always highly read-only type, no writing, no changing of the history. So write operation is not allowed. Then usage-wise, very structured data and quite ad hoc in nature. Response time-wise, it may take several seconds to minutes to process this data, but it gives accurate information. That's why nature-wise, OLAP systems always behaved very differently from the traditional transaction systems. There is a popular features called FASTME test. FASTME, F stands for fast. OLAP features are all fast, analysis, shared, multidimensional information is stored in a OLAP system. Fast, analysis, share, multidimensional information. So queries are executed in a fast. Analysis is done, A for analysis. Shared information is there. Multidimensional, different dimensions are taken into consideration. And then I stands for information. Then what is the support? Support is given, a little bit support is there in SQL. See, you all know that spreadsheets. Right? Simply, I will explain what is. You are all familiar with spreadsheets. You know how to enter data in a spreadsheet columns, and then how to do summaries, how to do sum, average, max, minimum, etc. with formula based. That means what? Every cell value in a spreadsheet is computed and value is entered based on the formula based on the value returned by that function, right? So that's called spreadsheet. Spreadsheets are always done. So that influence is there here. OLAP is a power of spreadsheet and power of SQL. Spreadsheet power is also embedded here. In SQL we store data. In spreadsheet also we store data. But the size of the data stored in spreadsheet is very limited. You cannot scale it up. But whereas in databases, sky is the limit. Data size can be scaled up in a big way. So therefore, scalability and computation power, both are tightly integrated in OLAP. That's why OLAP is influenced. It means what? Power of SQL is borrowed and power of spreadsheet is borrowed, and then put it together, stitch it together in the OLAP system. That's why the OLAP system is highly influenced by SQL and by spreadsheets. Then popular operators are very simple extensions of group by class. In SQL, there is a class called group by class. Here I will explain what is group by class. Suppose take participants data. Simple example I am giving. I have taken all your participant data. Different participants are there in my database. Some are professors, some are associate professors, some are assistant professors, say. Some are lecturers, whatever it may be. When you take this, suppose I want to get how many professors are there, how many assistant professors are there, how many associate professors are there as participants in my course, right? So here I will explain, because I will shut off this and then I will explain here how the example, right? So when you want to do this, you have a data. I know Dr. Vani is her designation is assistant professor, and she is from some particular department and from particular college, particular city and state, district. Some data is there with me. Similarly, Anjaya data is also there. Naresh Kumar data is there. So for each person, I store data in one row. So I have say 70 participants, 70 rows data, 70 rows are there in my database. One row for each participant, right? Now what I want to do is, I want to group this data into three parts. One part is all professors, another part is all associate professors, another part is assistant professors. So that means what? I am dividing these 80 rows into three disjoint set of groups. I cannot say that a participant belongs to professor as well as associate professor. My data is accurate, exact, correct, consistent. So what I do is, I divide the three disjoint groups. One group is a professor group data, another group is a associate professor group data, another group is assistant professor data. And then for each group, all the cadre designation is same. Now I have to make a count. How many are there professors? How many are there in associate professors? How many are there in the assistant professors? So that means what I am doing, my data, 80 rows data, I am summarizing into 3 rows with the designation, cadre, as a designation and count total numbers. So that means out of if you have a table of 80 rows, this table is now divided into 3 parts, and then each part total rows are computed, total count is computed, and then generates a 3 by 2 table. 3 by 2 table means 3 rows, 2 column table. First column is designation, second column is count. Right? Is it clear? Is it clear? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. So
Yes, sir.
now this, how do I do this? To do this in SQL, what we do is I will put this entire 80 rows table as a participants table. Then what I do, select. I want to select. What I want to select? I want to select the designation. And then what, with the designation, what I want the count of the designation. So select count star from participants table. Group by designation. Designation is a column, attribute name or column name. In Excel also we give names, right? We can do pivoting, dashboard, etc. You can do it in Excel also. So group by designation, then it will give 3 rows. So that means what? From the summary of 80 rows, I am getting 3 rows. How many professors are there? How many associate professors are there? How many assistant professors are there? For the purpose, we use group by class, right? So this is what I want to explain here, right? Popular operators are, it is a group by, not only group by class, it is a group by class with some extension. Some extension is nothing but, say for example, from the participants data, I get a professor 22, associate professor 34, and assistant professor say 10. Now, by seeing this result, as an analyst, I will say how many professors, what are the total people, total participants, how many are there? That I can see from this only, right? From this three column table, instead of going to my original table, I can compute by summing of all counts of these 3 cadres together. So it gives the total faculty, right? So the one that is called extension, simple extension of group by class. So I gave one example for 1 column. Imagine you have a course, teacher, student, marks. Then I want to say course teacher combination marks, student course combination marks, and then teacher student course individual marks, etc. Then we get several summaries will be there. Those summaries are called simple extensions of group by class. So therefore, in any OLAP query, whenever you write a OLAP query, it is always linked with the aggregation. Aggregate a measure over 1 or more dimensions is taken care as a common operation. In the earlier example, I have taken participants as 1 dimension. I am aggregating participants over cadre designation. So therefore, I get simplified rows. So that's what the OLAP does is, right? So OLAP queries always see, that's why it gives find total sales, find total participants. So for total participants, I can answer in 2 ways. I can count every row from the original table and then I can print. Another way is I can take sum of 3 rows only because this is already there with me. So when you have 2 channels, which one is faster? Computing sum from 3 rows is much faster than computing sum from 80 rows. Similarly, if I take sales for each city and for each state, I want state-wise sales and city sales. If I take city, if I know city sales, I can find the state sales also, right? Then what are the top 5 products ranked by total sales? So here we do top N analysis. Who are the top 5 best students of your class? Who are the top 5 best faculty in your class, in your college? So this is called top analysis, top N querying, best people. So that can always be considered by using aggregation. You can do all these things, right? So therefore, OLAP tools are basically helps you to do the more analysis quicker, smarter, and easier. So therefore, it is why we should separate. If you don't separate, what will happen? I will explain. Then you will understand why you should separate. If a normal day-to-day operation of the attendance system and also the analytical query, both are posed to database. Database normally takes more time for analytical query to answer because more competition is there. So in order to execute both the applications fast, easy, and simple, quicker, we are separating out. That's why we will empower the end users to perform his own analysis by playing with the structure that is created using OLAP software, so that he can view the entire 360-degree view of data with different combinations. And in the process, it is highly flexible. So it is an information systems backlog of report request reduction. So there is backend queries, waiting time may be reduced. So the reduction means what? Waiting time we reduce. More jobs we can do, more short time jobs. Short jobs can be run quickly if we separate the tool. If you combine everything and keep it in one place, the lot of delay will happen, and ultimately very few jobs are likely to complete in a time. And another advantage is it is ease of use and ease of understanding. Simple. And it views data from all angles. So therefore, to overcome all these things, we separate and then build that OLAP application separately. Right. So now I will take few questions here. Then we will go to the next topic. Any questions? Any questions, please? Hello? Yeah, Naresh Kumar.
No, sir. Carry on, sir.
Clear? Okay. Okay, shall we continue?
Yes, sir. Please, sir.
Yes, sir.
Okay. So now I will talk about how transaction systems are different from OLAP systems. There are 12 different comparisons are there. OLTP system is a transaction processing system. It uses day-to-day operations, operational databases, and decisions are very fast decisions, short term, quicker decisions we should take. And to fulfill the orders, demands, and resolve the ticketing, complaints, provide staffing, everything we need to take decisions faster. We cannot delay. Jobs are quicker, so short-term decisions. But OLAP takes analytical processing system in the sense that it may take some time, but the decisions are based on the analytical. Unless we observe the analytical data, we don't take decisions. Now, from the comparison point of view, I gave a table here. Users, who are the people going to use OLTP system? The people who are going to use OLTP system are clerks and IT professionals. Who are the people going to use OLAP system? Knowledge workers, business users. Knowledge workers is a high-level worker than the clerk and IT professional. Clerks and IT people, they do always day-to-day simple jobs only. Whatever the work is, for example, in any or institute, decisions won't be taken by clerks. Decisions are taken by the high-level people. So knowledge workers are high-level executives. Function-wise, day-to-day operations are performed in OLTP system. whereas the decision support system based operations are performed in OLAP system. Then design point of view, application oriented design is used in transaction system. Your booking of a ticket, cancellation of a ticket, and then savings bank account application, fixed deposit application. To run that application quickly, we are designing the data which suits the application. That means application centric design used while designing the structure of the database. But whereas in OLAP system, we use decisions, subject-oriented decisions, subject-oriented dimensions are used. We don't care how each application is running at the back end, but we always care how decision is to be taken based on subjects, without worrying about how customer is represented, how students are represented, how teacher is represented, but what is the relationship, what are the decisions need to be taken on the combination of all students versus all teachers versus all subjects versus all grades. So that's got subject oriented. And then data wise, data is always current data. In OLTP system, data is always current. Current means latest. You cannot go to ask, you cannot ask in bank what was my balance on 1st January 2024. Whenever you go to bank, you always ask what is my current balance. To withdraw money, you will ask current balance. So therefore, data in transaction system is always up-to-date data, current. Detailed, flat, relational database is taken into account. Detailed design, which transaction, when it is debited, where it is debited, at what time, all those details will be there. But whereas in OLAP system, data is always historical, summarized, multidimensional, integrated, consolidated. So all data is reduced into a good structure, highly condensed structure. That's why archival data, multidimensional data, historical data, summarized data, and the data is collected from different sources. All these things are taken care in the OLAP system. Then usage point of view, the data, the same application is repeatedly used by different users at the same time simultaneously. Say millions of users are booking the same ticket by using a IRCTC reservation of booking of a ticket application. But whereas here the usage is quite static. What I want to do the analysis that may change based on your analytical strategy, based on your management perspective. But there is no question of repetition. Today you may run one application darkly and tomorrow you may do something different, because analysis always varies based on the situation. Then access point of view, read access and write access, indexed scans, on primary key it is used. But whereas here access is always multiple scans are there. Unit of work point of view, short and simple transaction. Quickly you have to commit. Quickly you have to revert the bank, the operations on your savings data. Whereas here queries are always complex in nature. Number of records accessed is very limited number of records in OLTP compared to OLAP. If you access tons of thousands of records in OLTP application, here we take millions of thousands of records. So that many records are used here. That's why it takes more time. And number of users point of view, thousands of users may be there, hundreds of users may be there in OLAP system. Right, hundreds of users may be there in the OLAP system. Size point of view, 100 gigabytes to 1 100 megabytes to 1 GB size data. Here 100 GB to 1 terabyte data. So comparison point of view, it is almost 100 times double. The metric used is transaction throughput is optimized, but whereas here query throughput is optimized. Query throughput is optimized and response time is optimized. Right? So this way, OLAP system is different from OLTP system, and analytical processing is quite different from transaction processing. So therefore, highly summarized data is used. It is used for decision making purposes, and the queries are quite ad hoc in nature. the complex queries are used. Millions of users, millions of records are accessed with limited users, and size wise is very large, and response time must be faster, quicker. So therefore, query throughput is optimized. Here, transaction throughput is optimized in the OLTP system. This is how you can compare the OLTP with the OLAP system. So therefore, all these parameters are taken into consideration when we compare the OLTP with the OLAP system. So all the things are I explained. Now I am leaving this for a reading purpose. If you have any doubt, we can take it again tomorrow. So with this, I completed the first portion of my lecture, comparison of OLAP with OLTP, and how OLAP, what is OLAP, how OLAP is different from OLTP, and what are the, how we can compare all those things I have discussed today. So tomorrow I will talk another topic on multidimensional modeling, because the same day if you put everything in one go, it is difficult for you to understand. That's why I will stop here, and then I will take questions from the participants. So questions, please.
Sir, good evening, sir.
Yeah, good evening, Arun Kumar.
Sir, these OLAP and OLTP, these concepts, can it be applied for big data analysis also, sir?
Yes, good question. See, OLAP, big data analysis, and also is there, analytics is there, right? Big data analytics is again divided into different categories actually. Your descriptive data analytics, your big data takes different types of data, but structured data also may be there. But prior to the advent of big data analytics, these descriptive analytics came into existence. So when your data is structured and your size of the data is very large, then you can apply. But if you want to apply on a heterogeneous data of different types, audio, video, etc., then you have to make conversion systems. You have to use different kinds of tools depending on the nature of the model. So there are different types of big data models are there. So you cannot directly apply, but if the big data in the name itself is there, if data size is very large, big means what? Not only 1,000 terabytes, it is thousands of terabytes. In that case, it's called big data, voluminous, highly voluminous. So when that situation also you can apply, but it takes a lot of time. That's why what we do is we build different types of intermediate platforms. In a simple way, I will tell you a simple way. Suppose a student asks, sir, what is my total marks in my paper on your subject? Okay, this simple example. So how do you, there are many ways of telling the answer. How many ways are there? If a student asks, what is my total mark I secured in your paper?
Yeah, sir. It's
how do you answer?
It's like summing all the marks question wise individually, and then when you submit, we get our
summing all marks question wise individually. Sometimes questions may be having bits also, sub bits also. So all the things you need to sum it up, and then you should say that you got this many mark. Okay, that is one way. What is the other way? Suppose normally in our attendance register, we always put total marks in the register.
Yes, sir.
So by seeing his roll number, we will ask what is your roll number. So which one you prefer? Will you refer the register or will you refer the question wise totals?
I'll refer the register, sir, last column.
Why?
Because he asked the question that what is my total marks.
No, because that is one thing. And already you have computed and then pre-computed well in advance.
Yes,
pre-computed and posted the marks here, right?
Yes, sir.
That's why
Yes, sir.
you will answer from the fast way rather than going for the routine mundane procedure, right? The same logic is also applied here, you see. If you have a large data, millions of data, and you are looking for a summary, some summarized information. So that summarized information you can get in a different ways.
Understood.
But no system will take summarized information, the query to follow the root procedure. right? So that's why these are alternatives. Big data analytics also will have a lot of alternatives. OLAP is one kind of alternative. OLAP is one kind of alternative. It is known as a cube. Cube means what? In the three-dimensional structure, cube is there, right? We have you can rotate the cube. I can horizontally summarize, vertically I can summarize, or I can I can cut the cube. I can cut the cube vertically, horizontally to answer my questions, right? So these are called summaries. So tomorrow we talk about this OLAP, more detail about the multidimensional modeling. So there are many ways of answering, but this is the faster way because we have pre-computed well in advance to answer your query. So therefore, if big data is a structured data, you can use some mechanisms to speed up the queries, and then you can use OLAP also on that. But if your big data, your volume, variety, velocity are more, then you cannot apply. So again, it is specific to your application needs. This is one kind of method for certain kinds of applications. This is always best. For that situation, we use OLAP. Because by everything no software is best for all purposes, right? Every software will have the pros and cons. So based on the advantage and necessity, we have to choose the software. Okay.
Yes, sir. Got it.
Is it
Sir, one small thing,
Yeah.
sir. If we consider the Infosys company product, Finacle, sir. Finacle.
Okay.
Sir, is it a structured query? I mean, like is it a structured, organized data on which we are putting queries? Or else now Infosys has updated it with big data analytics also, sir. That
No, they see, everybody will say, every industry says my tool is big data analytics tool. What they do is backend, they have to write a lot of code, and then you have to run the code to transform the data into the way you want. Ultimately, in what format you want to keep the data ready for analysis is in your hand, right? So all these tools are helpful for you to manipulate and then transform the data. That's why your ETL, extract, transform, load.
Sir.
This P is meant for that only. So all these tools will give facilities for you to do the manipulation based on your type of data, right? But no tool say that you can do everything. No, it's not possible.
Understood.
Okay?
Thank you.
Okay.
Thank you very much,
Right.
sir.
Yeah. So any other questions? Hello? Hello? Why do you have multiple databases by different companies? Okay. Multiple databases. See, different companies may do business on the same kind of activity. But when I want to do the analysis to identify which company is doing better on something, so that if I want to beat the company, I have to find some strategy. So in that case, what I do, I take their results from different databases and then structure into my form so that I can do analysis by comparing the performance of one company with another company. So companies are always takes multiple different databases into consideration. For example, head of the ministry may decide an award, best education award for an institution. How do we do? For a student, best education, best as possible, outgoing student will be given. So in your college, you will recommend one person. How you might have used some process to identify the best student. In some other college, they may identify some process to best student. So what we do is we collect all the data related to each best student of every college, and we will consolidate from different databases. Data is taken, and then different types of formats are used by each database, and that will be combined here, and then identify the best one. So for that purposes, we always cross databases are taken into consideration. Therefore, single database is not enough. That's why data sources are, each data source can be considered as one database. So when you see the architecture yesterday I gave, different architecture sources may be there. Some data may be there in the flat file, some data may be there in the Excel sheet, some data may be come from structured database, some database may come from a hierarchical database. So these are all heterogeneous databases. So from all this data, you are grouping and then extracting the relevant data by running the queries. So it is architecturally different, but analytically you want to bring everything into unified framework. So for that purpose, we use this multiple databases. Clear? Venkatesh, Venkat Suresh, is it okay? Do we have the facility to store image, voice data? Yes, we have different types of databases are there. I will explain different database tools. Different database tools are there. In Google, if you Google it, we will store the data in the form of video data in the folder, and then that links are stored in the structured manner, so that you cannot write a query to get a part of the video. You have to cut the video to get the query, right? So that comparison is done backend differently. So for that, there are different routines will be there. But normally in lectures, we talk about more structure better, because the query language is there. Every MongoDB database, MongoDB, Cassandra, these are all different types of data, heterogeneous databases are there. Those databases uses these facilities. So you can have, okay? OS, data type, everything will be there. They are called different data types, right? So you can take date data type, you can use integer data type, or video. The video can be stored in external medium, and then link can be stored. So these are all possible. Okay? Okay. So if there are no other questions, we'll stop here for today. Tomorrow we'll continue the multidimensional model. Okay? Okay. Thank you all.
Okay, sir. Thank you, sir.
Okay, sir.
Okay.